Hi, this is Albert Nixon, Assistant Professor, Department of Chemistry, St.Joseph's College of Arts and Science, Autonomous, Cuddalore. In this video, we are going to discuss about polymer chemistry. Introductions about polymer chemistry. The word polymer is derived from Greek word poly means many, mer means units or parts. Polymers are generally macromolecules formed by the repeating, linking or large number of small molecules. Polymers are widely used in automobiles, defense, electrical goods, and computer components, and etc. The otherwise called many small molecules can combine to join in a various way to form macromolecule. That macromolecule is called polymer. One simplest example of polymer is polyethylene. Is a polymer formed by a repeating linking of large number of ethylene molecules. So here ethylene will undergo polymerization to give polyethylene. So here monomer is ethylene, polymer is polyethylene. So monomer is small molecules. Some monomer and repeating unit of the polymer is given below. So this side is monomer, this side is repeating unit or polymer. So ethylene to give polyethylene, propylene to form polypropylene, vinyl chloride to polyvinyl chloride, styrene to polystyrene, acrylonitrile to polyacrylonitrile, vinyl acetate to polyvinyl acetate, acrylic acid to polyacrylic acid, methyl acrylate to polymethyl acrylate, methacrylate to polymethyl acrylate. It is simply called PMMA. Then tetrafluoroethylene to Teflon. It is nothing but polytetrafluoroethylene. Next, butadiene to polybutadiene, isoprene to polyisoprene, chloroprene to polychloroprene, vinyl alcohol to polyvinyl alcohol, then ethylene terephthalate to polyethylene terephthalate. It is two different monomers like epichlorohydrin and bisphenol to form a epoxy resins by the removal of HCl, simply called dehydrohalogenation. Next, extra methylene diamine and adipic acid to give nylon 6,6 and caprolactam to nylon 6. Then amino teconic acid to nylon 11. Polymerization. Polymerization is a process in which a large number of small molecules called monomers combine to give bigger molecule. That bigger molecule is called polymer. Degree of polymerization simply called dP. So number of monomer in the polymer is called degree of polymerization. It is simply represented as degree of polymerization is equal to molecular weight of the polymeric network divided by the molecular weight of the repeating unit. It is nothing but monomer. Here I give one example, simple example. 5 moles of ethylene molecule will undergo polymerization reaction to give a polymer. So here we take 5 monomer. So the degree of polymerization is 5. So in the case we if you take 10 ethylene, the degree of polymerization is 10. If you take 100, the degree of polymerization is 100. Right? So number of monomer in the polymer is called degree of polymerization. Oligopolymers. Polymers with low degree of polymerization are known as oligomers. So the molecular weight ranges to 500 to 5000. High polymers. Polymers with high degree of polymerization are known as high polymers. They are ranges from 10,000 to 2 lakhs. Classification of polymers, they are based on source. So it is classified into two types. One is natural polymer, another one is synthetic polymer. So polymer is classified as two types. So in the last slide we discussed, one is natural. That natural polymer is further subdivided into two types. One is inorganic, another one is organic. In the case of inorganic, silicates is nothing but clay. For organic, proteins, polypeptide, RNA, DNA and cellulose. In the case of synthetic, here also two types, inorganic and organic. In synthetic organic, silicones. Synthetic organic is polyethylene, polypropylene, polyurethane, polyester, etc. Natural polymer, the polymer obtained from the nature, for example plants and animals, is called natural polymers. So here I given some example, starch, cellulose, proteins, nucleic acids and natural rubber. These are all comes under natural polymers. So next, isoprene to polyisoprene is a natural rubber. Second one is synthetic rubber or polymers. These type of polymers which are prepared in the laboratories are called synthetic. They are otherwise called man-made polymers. So these are all called synthetic polymers. For example, PVC, polyvinyl chloride, polyethylene, nylon, Teflon, bakelite and derivatives. These are all comes under synthetic polymers. Synthetic polymer also called another type semi-synthetic polymers. So synthetic polymers which are prepared in the laboratory are known as synthetic polymer or man-made elements. So examples are already discussed. Semi-synthetic polymers obtained by making some modification in natural polymers by artificial means are known as semi-synthetic polymers. For example, cellulose acetate, it is known as rayon, then vulcanized rubber. Next, classification of polymers based on structures. Linear polymers, these are the polymers in which the monomer unit are linked to one another to form a long linear chains. These linear chains are closely packed in space. It is an example of linear polymers. Next one is branched polymers. So in the branched polymers there will be some substitutions are there, that's why it is called branched polymers. Then cross-linked polymers or network polymers are otherwise called three-dimensional polymers. Here there will be a lot of substitutions are there, that's why it is called three-dimensional or cross-linked polymers. It is another bakelite is a good example. Bakelite is nothing but phenol formaldehyde resin. Next, plastics are high molecular weight of organic material that can be molded into a desired shape by the applications of heat and pressure in the presence of catalyst. Originally, plastics were discovered and then developed based on trial and error method. The present time in some time referred as plastic age. So now we are in the plastic age because the use of polymeric material is high. So there will be a large variety of applications. This rapid growth has taken place only in the last 15 years. So almost the 1917, after 1917. It was man's desire to develop plastics for engineering applications to replace glass, metal, ceramic, wood, and other materials of constructions. Since plastics possess the following advantages, they have wider applications. So, some advantages of plastics: they are lightweight material, they possess low melting point, they can be easily molded and have excellent finishing, they possess very good strength and toughness, they possess good shock absorption capacity, they are corrosion resistant and chemically inert, they have low coefficient of thermal expansions and possess good thermal and electrical insulating property, they are very good water resistance and possessing good adhesives. Here disadvantages of plastics, right? Softness is a first disadvantages, and embrittlement at low temperature. Then another third one is deformation under load, low heat resistant and poor ductility, compressibility, degradation upon exposed to heat and UV radiations, and non-biodegradable. These are the major disadvantages of plastics. So, classification of plastics. There are two types of plastics. One is thermoplastics, another one is thermo settings. Right? Here thermoplastics example: polyethylene, polyvinyl chloride, polystyrene, and PAN, polyacrylonitrile. These are the example of thermoplastics. And the thermo settings: bakelite, polyester, urea formaldehyde, and epoxy resins. Right? So epoxy resin is epichlorohydrin and bisphenol resin. Here I explain some difference between thermoplastics and thermo settings. Right? They are formed by the addition polymerization. Here the thermoplastics. Thermo settings is condensation polymers. They are consist of linear and long chain polymers. In thermosetting resins, they consist three-dimensional network structure. All the polymer chains are held together by weak van der Waals forces in the case of thermoplastics. In thermosettings, all the polymer chains are linked by strong covalent bonds. They are weak, soft, and less brittle. They are strong, hard, and more brittle. The important point: they soften on heating and harden on cooling. In the case of thermosetting, they do not soften on heating. They are soluble in organic solvents. In the case of thermosetting, they are insoluble in organic solvents. Classification of polymers based on mode of polymerization. So there are three types. One is addition, and second one is condensation, then third one is copolymerization. Addition, or otherwise called chain growth polymerization, it is a reaction that yields a polymer which has an exact multiple of original monomeric molecule. The original monomeric molecule usually contain one or more double bonds. In this addition polymerization, there is no elimination of any molecules, only addition, there is no elimination. That is the simplest example. So ethylene to give polyethylene. It is the simplest and best example of addition polymerization. Right? Next, PVC is another example. PAN. Next, condensation polymer. In this polymerization, by the removal of simple molecules like called water molecule, methanol, and HCl. The best example is nylon 66. So in the nylon 66, hexamethylene diamine and adipic acid to give nylon 66. And another example is nylon 6. And third one is copolymerization. It is a joint polymerization in which two or more different monomers combine to give polymers. So it is also also called heteropolymers, right? The monomer is different, two different monomers we used. The example is butadiene and styrene. It is an best example. Here vinyl chloride and vinyl acetate. Thank you for your patient listening.